Hey, welcome back. We're going to start talking about the applications of differential equations, and this is really big on the AP test. Remember, this is worth 9 points, and typically the average is pretty low on the AP test, so this is a really good chance to earn up a lot of points. So let's see what they say here. This says the rate of change of the number of porgs n is directly proportional to 1200 minus n. Now this should look familiar. This was in our notes from yesterday, so you can look back at my video on that one to talk about how we can set this up. But the big key word here is the rate of change. Remember, anytime we see the phrase rate of change, we're looking at derivatives. So we're looking at the derivative, the rate of change of the number of porgs is directly proportional to 1200 minus n. There's that is, there's our equal sign. So the first thing we're going to do is, before I do anything, is set up my derivative. Now, we know that my main function, my function is n, but what's n going to be in terms of? Well, they say where t is in time and years. So obviously we're going to be in terms of t. So when we write our derivative, we should write this as dn with respect to t. So dn dt. And then it talks about that word directly proportional. That means we're going to multiply by some constant of proportionality, k. So that's going to become k times 1200 minus n. So there is our derivative, our rate of change. Now they tell me when t is equal to 0, the population of porgs is 300. So they're giving me this condition. And then they give me another condition. When n is 4, the population is 600. So they gave me two conditions right here. We'll talk about that in a minute. Then they say, how many porgs will there be in 7 years? Round to the nearest whole number. Find the time t when there are 900 porgs. Alright, so obviously we're going to have to solve for n. And that's going to be our first step. So before I do anything else, I'm going to solve for n here. So to do that, we're going to separate our variables. So I'm going to bring the 1200 minus n over. So we get 1 over 1200 minus n dn. Remember, don't move the constant. Leave that here, k dt. And remember, the AP will give you 1 point for that. And so will I. I'm nice. When we integrate now, we're going to get the integral of k is kt plus c1. Remember, this is worth a point right here just for having that plus c. Integrating the left side becomes a little bit more tricky. We have to use a u substitution. U here will be 1200 minus n. My du is negative dn. And that's all I really need. I'm going to multiply by a negative when I take my antiderivative. So again, this is the antiderivative, 1 over u, which of course is natural log of u, but our u is just 1200 minus n. Now, don't forget that negative. We put it out here to the front. Remember, this negative came from our u substitution right here. So we have to include it. That's why this u substitution step is very important for it. It reminds me to put the negative here. And you'll get a point for that too on the AP. Now, I want to solve for n, but I don't like this negative where it's at. So what I'm going to do is I am now going to divide by negative 1. So when I do that, this of course just stays natural log 1200 minus n equals, and now take a look here, when I divide k by a negative 1, that stays k. It's just, remember, k is just a constant. So if I divide k by negative 1, it stays k. So I get kt plus, and if I take this c1, divide it by a negative 1, that becomes c2. It becomes another constant. So we're just dividing by negative 1. That's the nice things about constants. We really don't have to worry about them because they just get absorbed. K is a constant, c1 is a constant. Now remember, on the AP, if you leave this as k and this is c, they're okay with that, so are we. But you don't have to write the subscripts for k. Alright, next, now we have to solve for n. Now we're ready. We're going to exponentiate. So we get the absolute value of 1200 minus n equals, now remember this is my algebra step, because I'm adding the exponents means that they have the same base. I was multiplying two exponential functions with the same base, e to the kt times e to the c2. And this is what we wanted. Remember, show the step. We wanted this e to the c2. So we're going to write this as let e to the c2 equal c3. And now I can write this as the absolute value of 1200 minus n equals c3 e to the kt. Solving, we would get 1200 minus n equals plus or minus c3 e to the kt. And I like to solve for n. If I solve for n, I'm going to divide by a negative, but that still stays plus or minus c3 e to the kt. This becomes minus 1200, but I'm dividing by negative, so I get plus 1200. And there is our general function right here. This is the one I tend to prefer to use. Now, notice we have to find two values. We have to find C3 and K. And this is where it gets a little bit trickier for us. We have to find both C3 and K. So I need more than just one condition. I'm going to need two conditions. So how do I get those two conditions? Well, that's when I go back up to my problem. Remember what they told me. When t is 0, the population of porgs is 300. So they're telling me when t is 0, I'm going to write it as a table. I promise you this helps. The population was 300. At 4, the population was 600. Given those two conditions, I can now solve for C3. So the first thing I'm going to do is I am going to use my first condition, 0, 300, and I'm going to plug that in. Now, notice we're using the positive, so I'm going to go n equals positive C3 e to the kt plus 1200. Plugging in my values, I'm going to get 300 equals, if I plug 0 in here, that's e to the 0. So we're just left with C3 e to the 0 plus 1200. So that's easy enough to solve for. C3 becomes negative 900. So n would equal negative 900 e to the kt plus 1200. Now I still haven't solved for k yet, but I still have one more condition. So now I'm going to use my second condition for 600. Plugging it into my new formula, we would get 600 equals negative 900 e to the t is 4, so we get 4k plus 1200. Solving the exponential, first thing we're going to do, we're going to subtract 1200 and then divide by 900, negative 900, so that becomes 2/3 equals e to the 4k. That's just algebra right there. Solving this one, we can take the natural log of both sides. Natural log of 2/3 equals, take the natural log of here, we just get 4k. Therefore, k, and now I've got to use a calculator. So k, I'm going to take the natural log of 2/3 and divide that by 4. I'm going to put a decimal there so I'll make it decimal. I get negative 0.1014. Now, if you want to be more accurate, you would write it this way. Natural log 2/3 over 4, and that's what you could use. So what's my equation now? N would equal negative 900 e to the negative 0.1014 t plus 1200. And there's our final equation right there. Now we're still not done, okay? So I ran out of room down here. We're still not done because remember, we want to find out how many porgs when t was 7. So what we have to do now is find n of 7. And that's just plugging into our equation right here. So if I just plug 7 into my equation, negative 900 e to the negative 0.1014 times 7 plus 1200, and I get, be very careful, I'm going to get 757.432, but you can't have 0.432 porgs, so I'm going to round it, and the 4 tells me to round down, so we're going to keep the 757 porgs. Okay, the 0.4 tells me to round down. Round carefully, okay, because they say round to the nearest whole number. 0.4 says to round down. Be very careful. Alright, hope you guys enjoyed that video. Go to part 3, we'll take a look at the next example.